Okay, more of 3.1. If our equation is not in vertex form, it looks like this instead. This is actually called standard form. Which we'll learn more about coming up. If it's in standard form, we can complete the square to get it back in vertex form, and then we could do the same problems that we just did on the previous page. So let's see what that process looks like. I don't have steps written out. We're just gonna start and I guess write steps as we go. So the first thing I'm going to do is I'm going to replace my f of x with a y equals, just because I feel like it's more convenient to use y instead of f of x. Just like when I did completing the square before, I'm going to move the constant term over to the other side. So now I have y minus 3 equals x squared minus 2x. So I guess I'll write that. Move the constant term. Now this one does not have a coefficient in front of the x squared, but if it did, we would need to divide both sides by the coefficient of the x squared. In this case, it's just a 1, so we don't need to do that. And then the next thing we're going to do is set up for completing the square. So I will put my box here. I still have y minus 3 on that side. And I'll put x squared in the top left. And then remember that this minus 2x here, I have to split the minus 2x. So split the negative 2x evenly between those two spaces. So negative 1x here, negative 1x here. And then I have to figure out what's going on the outside edges so I can figure out what's going into this space right there. So what goes on the outside edges is going to be x and negative 1 and negative 1. Then I figure out the number that completes the square. So the number that goes into this space right here is negative 1 times negative 1, so positive 1. Since I added 1 to the right side, I also have to add 1 to the left side. So we are going to complete the square. And we have to remember to add the same number or the same value to the left side. If you forget to add that value to the left side, you're going to be in a mess. So after we've done that, then we're going to write it in factored form. So the right side will be x minus 1 squared. And the left side, in this case, I can go ahead and combine negative 3 and 1. You can't always do that, as we'll see in our next example. So that will be y minus 2. And then we're going to reverse all of the previous steps. So going in reverse order. Where I added a value to the left side, I'm now going to subtract it. Where I divided both sides by a coefficient, I'm now going to multiply. And then where I moved my constant term, I'm going to move it back. So really on this one, all I have to do is move my constant term back. So I will add 2 to both sides, and I will end up with the answer, actually. This one's going to be y equals x minus 1 squared plus 2. So now this is in vertex form. So I can see that I have a shift right 1 and up 2. So the vertex would be at 1, 2. I don't have any stretches or compressions, so I would follow the normal pattern of a parabola. So let's see the second one. It's a bit more complicated, but same steps. Move your constant term, divide both sides by the coefficient of x squared. So I'm going to start by writing y equals 2x squared minus 4x plus 5. So my first step was move the constant term. So I will subtract 5, subtract 5. So now I have y minus 5 equals 2x squared minus 4x. Okay. Divide both sides by the coefficient of x squared. So here's what we're going to do on that step. When we divide both sides by the coefficient of x squared, on the right side, I'm just going to divide each term by that number. On the left side, I'm going to keep the whole side over 2. So when I rewrite this, the left side is going to say y minus 5 over 2, and the right side is going to say x squared minus 2x. Next thing I need to do is complete the square. So I'm going to set up the box with my y minus 5 over 2 equals the box with x squared in the top left. Remember that I have to split that negative 2x evenly, so negative 1x, negative 1x. And then I have to figure out what goes in this bottom space. So x here, minus 1, minus 1. Negative 1 times negative 1 is plus 1. I have to remember to add the same value to the left side, plus 1. That's where that came in. Now I'm ready to write in factored form. So in factored form, I've got y minus 5 over 2 plus 1 equals x minus 1 squared. Now I get to reverse the previous steps. That's this step. So the last thing that I had done was add a value to the left side. That's the pink step. So I am going to now reverse that step by subtracting 1 from both sides. So now I have y minus 5 over 2 equals x minus 1 squared minus 1. The step before that, I had divided by 2. So now I'm going to undo that by multiplying by 2. So I'm going to multiply this side by 2. On the right side, I'm going to put a 2 in front of my parentheses, and I'm going to multiply this number by 2. So I have y minus 5 equals 2 times x minus 1 squared minus 2. And then prior to dividing both sides by 2, I had subtracted 5 from both sides. So I will undo that by adding 5 to both sides. So now I have y equals 2 times x minus 1 squared plus 3. So when I rewrite f of x, it is going to be 2 times x minus 1 squared plus 3. That is in vertex form. So that is going to give me a shift right 1, up 3. This is a vertical stretch of 2. So the vertex would be at 1, 3, and the pattern would be over 1, up, instead of 1, go up 2. Over 2, up, instead of 4, up 8. And then left 1, up the same as we did, and left 2, up the same as we just did. So we can complete the square if we have our equation given in standard form, but we're also going to learn other ways to deal with it if we don't want to complete the square. So I'm going to come back and do a separate video about if we don't want to complete the square, how we handle a standard form equation. Perhaps, maybe, if I can get my recording to stop.